So let us see that we can have to simplify the rational exponents. So what are the rational exponents? These are the expressions with the fraction powers. That's the rational exponents. So now the evaluation of the rational exponents basically uses the principle behind the laws of indices as well as the enthalpy properties. So having came across the laws of indices, the enthalpy properties, then the evaluation of the rational exponents won't be something difficult. So keep that in mind. So let us see that we can have to evaluate the following rational exponents and see the beauty of it. So let's say we have 49 to the power, let's say, half. So now, as it stands here, according to the laws of indices, the denominator of the power is given as the root, where the numerator becomes the power. So in this case, we'll have it as, so now, which means we'll have the square of 49 and overall to the power 1. So what is the square root of 49? 49 is a perfect square, so which is given as 1 to the power 1, which is actually 7 to the power 1, which is the same as 7. So that's how you can have to simplify that one up to. And what if, let's say we have this. Let's say we have, let's say 5 times a, and overall to the power, let's say, let's have this. 5 times a to the power, let's say, 2 over 3. And let's say times, let's say 4 times a to the power, let's say, 3 over 4. So how can you be able to simplify these actually expressions? And of course, we have the constants given as 5 times 4, or have it as 20. Of course, we have that and as that. And we have a, which is the a, and they have the rational exponents. So according to the laws of indices, we'll have it as a to the power 3 and plus 3 over 4, according to the laws of indices. So what is 2 over 3 plus 3 over 4? We have 12. You should have to understand how to add the fractions. So which means we'll have it as 9 plus, we'll have it as 18. So which means we'll have it as 17, and divide by 12. So that's the addition. So now which means we'll have it as 20 to the power 17 divided by 12. And of which this is actually a root, and this is the power. And further, we can have to simplify it as 20 now times the 12th root of a to the power 17. So that's the analysis. And of course, you can have to leave it at this point. You can have to just leave it at this point. It is fine as well. But keep that in mind. Now, what if we have this case? Let's say we have the third root, actually the cube root of, let's say 16 a to the power, let's say 1 over 2, and let's say divide by a to the power 1 over 4. So what is the principle behind this? And of course, having that, it is the same as the cube root of 16 a to the power 1 over 2, and then divide by the cube root of now a to the power 1 over 4. So now, according to the working principle, having this one, now this is the same as having it as now 16 a to the power half into overall to the power 1 over 3. And that is divided by a to the power 1 over 4 into overall to the power 1 over 3. So now, according to the principle behind the power distribution law, that is on the laws of indices, now this is the same as having it as 16 to the power 1 over 3 and the times a to the power 1 over 6, that is divided by a to the power 1 over 12. So that's how it has to be. And of course this is the same as having it as the cube root of 16 times the 16th root of, let's say, a divided by the 12th root of a. But it is the same just to have it in this position. And of course further using the laws of indices, by the way, let me just have to have this. We can further apply laws of indices in the sense that we'll have it as 16 to the power 1 over 3 times, since the bases are the same, it means we'll have a to the power 1 over 3, actually 1 over 6 minus 1 over 12. So try to have it out in that way. And what if we have, let's say, in this case, and let's see how we can be able to apply the principle behind that in the following problem. Let's say we have, in this case, we have negative 8 to the power, let's say, 4 over 3. Let's say that's the case, but let me just have to put it this way. We'll have 2 over 3. So now as it stands there, it means we'll have it as the cube root of negative 8, let's say, over the power 2. So what is the cube root of 8? We'll have it as the negative 2 to the power 2, that will be given as 4. That's the working principle behind that. How about if we have this case? Let's say if we have the square root of x times the 4th root of, let's say, y to the power 4, and let's say times x to the power 3. How should we have the problem it out? So now as it stands here, it means we'll have the x to the power half, just that, and the times now y to the power 4 and x to the power 3 and over to the power 1 over 4. And of course this is the same as x to the power half, and the times y to the power now should be 4 times 1 over 4, that is the same as y times x to the power 3 over 4. So these are the expression the same basis, so which means we'll have to add up the powers. So plus 3 over 4 times y. So try to have it out at your own time. Also think about this one as well. What if we have this kind of expression? Let's say we have it as, let's say, the cube root of, now should be the square root of x times the 15th root of, let's say, y to the power 4, and let's say over divided by, let's say, the 7th root of, let's say, a q to the power 4. So how should you have to simplify this one? So you should have to critically look at the problem that we have. You should have to apply the laws of indices where you can think you have to apply it, and the properties of the nth roots where you think you can work, and in that way. So where should we have to study it up to from? As much as we understand how to have the working principle behind the laws of indices and the properties of the nth roots and some other related aspects as far as the algebra is concerned, then this is true. In this case, this is the same as the cube root of, now square root of x times the 15th root of y to the power 4 divided by the cube root of, now should be that of the 7th root of q to the power 4. So bear that in mind. So now as it stands, that means this is the same as, now we should have it as the cube root of, now x to the power half in the times y to the power 5, now should be y to the power 4 over 5. So that is in the divide by, so which means we'll have it as the cube root of, now should be q to the power now 4 over 7. So bear that in mind. So practice will makes you perfect. So the more you practice, more examples, more exercises, the more you get used. The more during the typical exams or whichever or wherever you apply this, you'll be able to mastermind these things. So in this case, now this is the same as having it as now x to the power half the times y to the power 5 over 4 should be 4 over 5. 4 over 5 in the overall to the power 1 over 3 in the divide by q to the power 4 over 7 in the overall to the power 1 over 3. That is the working principle behind that. And what if now in this case we'll have it as x to the power 1 over 2 times 1 over 3 in the times y to the power 4 over 5 in the times 1 over 3 according to the power distribution law. The divide by q 4 over 7 times 1 over 3. So which means we'll have it as x to the power 1 over 6 times y to the power 4 over 15 and that divide by q to the power 4 over 21. So that is the solution. So just have to ensure that you are well familiar with the laws of indices and the properties of the nth roots, and everything will smoothly work. So in case you missed that, actually a tutorial video we discussed about the laws of indices and the concepts behind those things, just have to make sure that you watch it. Just have to check it in my playlist, and I'll provide the links in the actually comment sections below. Now what if we have this case? Let's say you have the 3 root of a to the power 2 plus b to the power 2 times, let's say, 2b. So what is the solution for this case? So according to the working principle, this is the same as a to the power 2 plus b to the power 2 to the power 2b in the times overall to the power 1 over 3b. And of which this is the same as a to the power 2 plus b to the power 2 to the power 2b in the times 1 over 3b, of which this and this will cancel. We'll have it as a to the power 2 plus b2 to the power 2 over 3. And of which, since these two values are adding, you cannot have to say a to the power 2 times 2 over 3 then plus. This is not accepted. So that's the working principle behind that, and it will end there as well. Now how about if we have this case? Let's say if we have, let's say, the 4th root of, let's say, 64 and the 8 to the power 2 over 3 and should be now like this. And the overall divide by, let's say, 8 to the power 1 over 3. So what is the working principle behind this? So according to the principle behind this is the same as the 4th root of 64 times 8 to the power 2 over 3 divided by the 4th root of, according to the laws of indices, 8 to the power 1 over 3, and of which this is the same as having it as now 64 times 8 to the power 2 over 3, and I overall to the power 1 over 4, and I divide by 8 to the power 1 over 3, and I overall to the power 1 over 4. So try to have it out at your own time. Also think about this one as well. What can be the working principle behind that? Let's say we have now, what if we have, let's say, a square of, that should be the cube root of square of x, let's say, plus the square of cube root of x. So what is the working principle behind this? So in this case, I'll have it as the x to the power 2 to the power half times 1 over 3, that is also as the power, plus x to the power 1 over 3 over the power 1 over 2. So in this case, we'll have it as x to the power 1 over 6 plus x to the power 1 over 6. So now, these are the like terms, we just have to add them. We'll have it as 2x to the power 1 over 6, and of which this is the same as 2x to the power 16th root of x. That is the working principle behind that. And also try to understand this one as well, how best you can have to go over that. What if, let's say, we have, in this case, so what if we have, let's say, the cube root of, and that should be 27 times the square of 64 times 6. So try to understand that and up to at your own time. And what if we have, let's say, 256, let's say, to the power negative 3 over 4, and overall times to the power 4 over 3. Try to understand that according to the laws of indices and some other properties of interest. You also try to understand this. We have x squared plus 1 over, let's say, x squared plus 1. Let's say this one is having 3 over 4. This one is having, let's say, negative 1 over 4. Try to understand that one. How best you should have to go over that. And also, what if we have this? Try to have it out at your own time. Let's say we have 2x squared plus, let's say, 1 to the power, let's say, negative 6 over 5. Let's say times 2x squared and plus 1 to the power, let's say, 6 over 5, and let's say times, let's say, x squared plus 1 to the power, let's say, negative 1 over 5. So it should be negative 1 over 5. Negative 1 over 5 divided by, so it should be negative 1 over 5 there. And divide by, let's say, x squared plus 1 to the power, let's say, 9 over 6. So it should be 9 over 6 rather. So what is the working principle behind that? Try to have that at your own time. So that's how you should have to understand about the way you can have to make use of the rational exponents in some typical different problems. Let's say you have this case, a fourth root of x to the power a times the cube root of x to the power b times the square of x to the power, let's say, a over 6. So what is the principle behind that? And you should also have to understand about, let's say, have this case, cube root of, let's say, x to the power 2 times the 15th root of, let's say, y to the power 4. Try to have that and out at your own. Thank you.